It's so weird getting used to looking at the light. What's up, everybody? Welcome back to Make It and Break It. My name's Andrew, and today we've got a bunch of tools in hand to start templating our crash bars for the HyperTenere. Hopefully that didn't break. Nope, still good. Okay, so we're back here, and we've been working on a bunch of our foot controls and stuff like that, and that stuff's getting finalized and sent out right now. But the next part of this project is some of our crash protection, and that's really what will get us from street bike with some off-road tires to actual adventure bike. The ability to take it off-road and take it into places that are more rugged than it's really designed for, and have a decent amount of confidence that it's going to come back again. And the crash protection is really what does that there. It's what lets you take it up rocky hills, sides, and up kind of sketchy places, but you know if it's going down, it's going to hit stuff that you want it to hit before it hits things like your engine case, or your radiator, or your oil pan, things like that. So today I was going to sit down and do some templating and validation of design for my crash bars, and I wanted to show you guys the templating method. So I'll talk a quick bit about templating and piece design, especially when you have the piece that's going to go on your target here. So I want to test out 3D printing here and see how we can actually get this done. So I'm going to do a sort of freehand template style. So this is a little bit more freewheeling. This is more finding the points that matter, which is typically your mounting points and anything you want to protect, right? Finding those things that matter and making sure they are covered by your tubing, and then kind of freewheeling the design from there, and hopefully it works out well. And the idea here is we're going to take some measurements and then go throw those into our CAD program, get ourselves a model of our crash bars, and then use that model to 3D print some test fit parts to make sure we like how it sits. The tools you absolutely need for this are some measurement tools. I have two here. This is a standard ruler. This is what you get in grade school, right? It's handy because it's flat, so I can measure flat stuff and flat faces and distances between faces that are pretty easy. I have this, which is good for longer distances, or for us, we're going to actually use it for the height here, and get these heights off the ground so that we can properly locate our major points. And an angle finder. So this made its debut on our last episode dealing with the foot controls. The angle finder, even though we're not using magnetic stuff, so the magnetic part is not really useful to us, it's really handy for getting orientations right on your kind of freewheeling parts here. So the idea here is that you can go set up one of your rulers, for instance, and okay, I need to go from here to here. What's that angle? Oh, that angle is 30 degrees, right? And it's 30 degrees below level, below horizontal, or it's 30 degrees above horizontal, and that'll help you in the CAD program, which I'll show you in a little bit. Now, a couple things that you might want, but are not necessarily required for this. If you're really smart, smarter than me, and able to keep all these measurements in your head, you won't need this, but I suggest having something to write stuff down. I like the whiteboards because I can wipe it off and redo it, and I can throw in my generalized idea of this sketch. It's going to be something like this, and then there's going to be something like this, right? Something like that, right? That's kind of, I can throw in a sketch and take some measurements and mark it up, but if I don't like how it's going, or I've realized something's wrong, it's real easy, and I don't have to go print off a new sheet of paper with my idealized sketch on it and throw it out. You can also use something like this. So this is a fit-up templating tool that we 3D printed a while back, and this one's actually designed to be used for the type of tubing that we're going to use here, which is 1-inch 083 wall tubing. For those of you in Europe or that use the metric system because it makes sense mathematically, that would be 25 millimeter, 2 millimeter wall tubing, roughly. Slightly larger on both of those, but if you're looking at crash bars and things like that, they're typically made in 1-inch or 25 millimeter tubing at about 2 millimeters of thickness. So I didn't feel like, you know, reinventing the wheel here. I didn't need to stress test stuff like that. Big 1200 GSs that are 700 pounds fully loaded have crash bars of this size. So my little R6 can easily have crash bars of this size. Finally, the last piece you might want is a roll of tape. I'm using masking tape here because it's easy to write on and see. And the idea here is that, let's say you want to mark spaces. I'm going to want to mark a couple things. You can just write on your motorcycle or write on your customer's motorcycle or car or whatever you're templating, but that's kind of in bad taste. So what you can do is mark it up there, and then where's my, say, okay, this is the line where we're going to come across, so I want it to be here, and then you can measure distances or things like that and mark where those parts are. And then when you're done, it's easy to just pull them right off. Or if you screw it up, you can pull it right off, replace it, and do it all over again. So you're going to want a little bit of tape, but it's not required. If you're really meticulous about it and not as scatterbrained as I am when I do this stuff, you probably actually won't require tape to do it, but it's really handy and it's nice to be able to have it to come back and reference. So what's the idea here? Well, our crash protection is going to go up here, and when you're templating the way I am, we need to identify kind of our boundaries, our major components, because if we just say, hey, build crash protection, that's not really helpful for getting the job done. So we need to identify both where it mounts and what it needs to protect. So mounting points are pretty easy. On the front of this motorcycle, there's maybe two-ish, 2.5, we're going to call it, reasonable mounting points for a crash bar. So the first two are pretty obvious. They're right here and right here. This is a main engine mounting bolt to the frame, and this used to be a mount for our fairing, so our fairings would bolt into this thing. Now, we don't necessarily need to use this anymore. The third one is actually up here on the front of the engine. It's hard to see from this, but I'll get you an overlay here. And on the front of the R6 engine, there's a couple tabs, one on each side, that kind of come off the front of the engine block. So that would also be a pretty good rigid mount. But that kind of gets right into where the exhaust manifold is and around the coolant hoses and things like that. So it gets a lot more complicated down there, and it's not necessarily symmetrical with both sides. And it would be ideal for us here to keep it simple and keep it symmetrical with both sides. So we've identified our two mounting points. That'd be this upper fairing mount here and this engine mount here. So we need to locate those at least relatively between each other, so we can throw them into a CAD program and be pretty sure that's going to be close when we go in and do our final sort of fit up here. So in this case, we're going to take this and create ourselves, you know, an X and an X. These are just placeholders here for our spots. We'll just call this M1 and M2, just mounting points for now. Then we need to basically locate these in two-dimensional space. So we're simplifying this design a little bit because we don't have kind of all the measurement tools I would love to have. And we're gonna basically build the entire we're basically going to build the entire crash bar in one plane. So we're going to build it in two-dimensional space. We don't necessarily have to locate in and out. We'll do that with our mounting system, which I'll explain maybe later in this episode or in the next episode. And then we want to identify kind of our major components that we want to protect. So most of the components are pretty easy. We want to protect the engine, which is kind of in this area, you know, right? Somewhere in that area is the engine. And we want to protect the radiator, which is somewhere up here. So the radiator on these bikes is not hidden very well, and they tend to run, this bike runs pretty hot anyway. So we want to protect that as much as possible. So the ideal situation here is a crash bar that comes out maybe something like this, comes down and follows the radiator, comes down underneath here, because this is maybe not the best. This M2 is probably in this situation with the engine coming along here. This M2 is kind of more like right up in here, right? So this is M2. So this is exactly why I dry erase. Kind of come along here and then come back up here. So this is kind of our first main hoop. And the idea here is this is creates a big flat plane that holds everything away from the bike. So hold the bike away from the ground and anything that's gonna kind of want to break it up. And then the other thing we're gonna want to do is make sure we have a cross connect between both sides, because that'll keep everything rigid and from like flexing in, especially these corners. If they have more connections, you won't have these corners flexing in. So what we're gonna do is have this waistband kind of come along here. This one we don't necessarily need to measure for right now. We can measure for it after we get this main hoop. But this main hoop is what's going to drive our design. So we want to measure for this thing, and then we can fit the rest of these pieces later. Because there will be this piece here, and there will be a cross connect from this point to the other side, which will be a mirror of this one. So what do we need then? We need, to CAD this up anyway, we need a distance from here to here, which is essentially a distance to the center line of your new piece. We would need this angle, you know, we'll call this theta alpha. Is that theta? I forget. It's been a while since I took math, guys. Angle alpha. We need this angle. We're going to call this angle beta, angle B. And then this is, I drew some of these with with sharp angles and some of these with curves. They're all angles here. Now we can make this simple for ourselves and make this a 90 degree, but that might not help us, and I'll show you why. And then we need distances. So we'll need some sort of distance between here and here, some sort of distance between here, and some sort of distance between here and here. That's an unnecessary line there. Right? So we'll need 3 angles, 3 distances, and then you'll notice that this doesn't really help us if we don't have these parts. So a lot like we were doing with the foot controls, we need to locate this distance between these two, here and here. We also would like to locate the distance, the heights from the ground. And ideally, what we're going to do is locate this. So we're going to call this angle M. Locate this angle here. That is the angle from vertical for this mounting direction, and that will fix these points in place and make all of these points also fixed in place. Let's get measuring, right? All right, GoPro hand cam here. Our main hoop here, our main crash bar hoop is done printing in translucent PLA because that's what I had loaded. So we're gonna pull this off here real quick and then go see if it fits together. Exciting. All right, word of warning real quick. I gashed the crap out of my hand. It's maybe hard to see here, but that is why with 3D printers, I do prefer using either flexible build plates or not using adhesive when you're printing, because those don't tend to hold on to prints when the build plate is cold like glue does. So the glue held on and I had to really get in there and lever on it, and the slipped and hit my hand and it's bad. So learn from my pain and don't do that. So we have our loop. So you can see I had to attach it, and you saw that in the time lapse. That's because it's too big. Well, I could have printed it like this, let's be honest. I could have done that, but that print would be very weird, and you might as well print it like this because then everything's built and has the same sort of weird idiosyncrasies in its like support structures and everything. So it all should line up a lot better if you print it on its side. However, this doesn't fit on a build plate on its side, at least not my build plates. So what I did, and in my slicer, I could actually slice this in different sections and create different smaller parts out of it. So I did that and made it 3 parts, and then I glued it, and then I didn't like the glue, so I duct taped it together, because duct tape is what you use when you don't want anything to move. So we have this back and together, and we have our stand-in mount. These are 1" 083, and this is also standing in for 1" 083. These mounts with a welded puck on the end for all the fasteners to sit on and hold in. So the idea is if I did my measurements correctly, and if I designed it and built it and the printer didn't screw up and all this sort of stuff works, this should just clip on over here onto these 2 pieces. So let's try it out. All right, so it fits. It in fact fits perfectly. I don't have to bend it at all in order to get it. So that means our measurements were great. One thing I would like to note is that I took measurements to locate these heights. You don't actually need to do that. What you need to do is just locate these 2 distances and the angle between each other, and that'll lock everything in with this and these ends. So a little bit of a change from what we did earlier, but everything hooks in perfectly, even with the coping that I put onto these things. So I actually printed in the hole saw coping to test if these endpoints would actually fit on these, and they do really well. That is easily well enough to weld these things together. So that's cool, and you can see, hopefully, I'll put this up here, kind of where it sits. So it's gonna sit a little bit weird right now because I don't have anything really holding it in, but that is the shape that we wanted to kind of get. So we run out here, and then it runs down parallel with the radiator, and in fact a little bit below. So I wonder, I'm gonna have to go take a look at the front here and see if there's enough clearance for me to do a crossbar, which is the other real main piece that we're missing right now. And then it comes back up and follows along the baseline here, and then comes up in front of the engine case right here. So this is really trying to prevent some like big hard rock from coming in and penetrating the engine case like that. That's the idea anyway. So if we keep something here, it'll slide the bike one way or the other, or it'll keep it up on the rock. And it looks like everything fits up well. One thing I am noticing, I'll get out of the way, is that I would really like to protect the clutch cover. So this is your transmission cover. This is your oil stuff. So this is your transmission cover right here. And I would like to maybe take a little loop like this and then meet back up in here, something like that. I think would be kind of nice. So that's something we can do. But the handy part is, because all of this stuff fits up great, we can actually just go design it and CAD it, and we don't have to like be worried that the endpoints are going to be missing. We just have to take a couple measurements, how far out we want it here, and then we can meet it right back up with our sketch to begin with. So that's really cool, right? So that's why it pays to do something like this if you want to design your piece. If you want to add stuff here and you have a CAD model, you literally just go in and add it, see what it looks like, and then you can make it or not, or you can make adjustments to it, and you have these perfect endpoints that work. So why did we pick this way? One, because it's a 3D printer, and this is a 3D printing, applied 3D printing channel, really, is what this channel is. But also it takes advantage of what we have for capabilities and doesn't require me to have a whole lot of manual skill. So in my old job, in a large industrial environment, if we were doing something like this, we had two methods that we used, and neither of them were this. We used this when we were doing tool design, which is, I got to do some of that, which was kind of fun. But we had two major methods that we used to use. One of them was a targeting method. This was the old school method, and targeting gets used when you don't want to fabricate your piece in place. Let's say it's in a weird place where you can't really get, and you have to like, you're shooting a piece of pipe through like 3 walls and across and everything like that. Obviously, it's hard to fabricate that piece in place. You probably want to fabricate that piece or smaller pieces of it separately, and then have them just do the final welding for like a piece of pipe, for instance, at the work location. So what we would do is we would take something like this, actually. So we would go and we'd take a piece of metal, say these pieces here are actual metal pieces, and then we would go and take angle iron, like some of the stuff that's behind me over here, or tube or flat stock or whatever, and weld them together at our major points. And so those would be the end points, or the targets that we would then have to go hit, and we take that target back up to the shop, and we then set it out in a place that was representative of the places we had to hit and miss and all that sort of stuff, and we could fabricate around that. That's one way to do it. In a garage setting like this, it's probably more time investment than you really want to put into something that's probably a one-off. Now, if you're working at a small business and you're going to build a bunch of crash bars like this, that can actually be useful, because you can take your target and build a fabrication jig off of that, and then you can just run it over and over and over and over and over and build like 100 of them in the time it might take me to build, like, you know, 2 or 3 of these targets, right? So there's still uses for this in a non-industrial application, but I think they're much less used than that. The other way that we would do it is we would actually take a coordinate measuring machine. This is like a little arm that goes, has a little probe on the end of it. Maybe I'll get a picture for you guys. And it actually keeps track of where that probe is in 3-dimensional space. And so you could map out where this is, and you could even go in and map, hey, we want to protect this piece and this piece and this piece, and import that into your CAD programs, and then use that as a backdrop for designing your piece, or validating that your piece is going to fit, for instance. So that's really cool, but those arms are not cheap, and I don't have a whole lot of use for them, so I don't have one. So those would be the two main ways that we would fabricate it. The other way to fabricate something like this is to just go do it. One, my skills are not good enough, but I'm sure there's many of you guys out there who actually have good fabrication skills. So you don't necessarily need the great plan that I do when I go into these things. I need a plan for it, because I need to know exactly how I'm going to get it done. Otherwise, I can't make up for the lack of plan with actual talent. But if you have talent, you could literally go create these standoffs, and then just take a little like rope and measure it out, and okay, we want to go out 90 and down, and then go down about 14 inches, and then just throw that on your bender and measure it out, and then okay, now we need to go back. You bring it back off your bender, and you're like, okay, well, now I need to go back 8 inches, and then it's a 90 back up, and off you go. Like, there's people out there that can do that. I am not one of them. Wish I was, that'd be sweet. But there's people that can do that too. But if you have a 3D printer and just basic measuring tools, you can accomplish really good designs and validations and function tests without a whole lot of effort. So I want to show you guys this templating method. yeah, hopefully you guys found this interesting and informative and maybe a little bit educational. I mean, I don't want to stray too much into educational territory. You know, this is just some dude in the garage. But I want to show you guys how you can leverage this sort of stuff on a pretty complex build and get some really good results. So I think we're going to stop it there. Thanks for watching, everyone. My name's Andrew. This has been a Naked and Break It. That's a different channel. Make It and Break It YouTube video. Our Project HyperTenere is moving right along, and we're going to start getting some crash bars fabricated here. So if you like this video, definitely hit like. If you have questions, comments, concerns, if you want to see some more of this stuff, I actually really enjoy doing this sort of design and fabrication. It's really fun for me. So if you want to see some more of this stuff, I can show you a bunch of different ways to use this sort of technology and design parameters to go about your garage work. So if this stuff's all really cool to you, definitely let me know in the comments down below, or if you dislike this video, let me know why. And if you like what we're doing in this channel, we got HyperTenere, we've got an RX-8 project, and then I've got an eye on a couple other projects that are coming along here soon. Then definitely hit subscribe, ding that bell icon, come on back and watch these videos, and if you're not too careful, you might even learn a thing or two too. So again, thanks for watching, guys. My name's Andrew, and until next time, guys, I'll catch you later.